Welcome to Unit 1, Lesson 14. This is Part 2. I think we have only 3 more problems to do, but as we said in Part 1, these problems, solving 3 systems with 3 unknown variables, they can be a little bit lengthy. The algebra isn't so difficult. It's multiplying, adding, subtracting, substituting back in to solve, but it's a lot of writing. So let's get our mind set to the point where we're going to have to write a little bit more than we're used to, but we're going to do it. We're going to take it at a decent pace as to not hurry and make a mistake, and we're going to get the answers right. Okay? I might be going a little bit faster on this Part 2 video than I did in the Part 1 because we've kind of already done the basics. So if you need to pause and rewind, go ahead. Feel free. Hey, it's your phone, your computer. Do whatever you want to do. Except don't go to that certain website. Yeah, I know. Don't go there. Anyways, let's solve the following system of equations. Okay? I said we have 3 equations with 3 unknowns. I have an x, I have a y, and I have a z here. But it doesn't look like every equation has all 3 variables. So this is what I am going to do. All right? I am going to decide which 2 variables I want to keep and which one I want to get rid of. And that's going to help me decide what 2 equations here I'm going to manipulate. Let me explain. Okay, let's say I want to keep an x and a y. So I have 4x plus 3y equals 4. That means I only need to get rid of my z with this equation and this equation. That's it. Once I get rid of a z there, I'll have a y and x left, okay? You could do this another way. You could want to keep the y and the z and try and get rid of the x or whatever. That's fine, okay? I'm going to keep the x and y. So, as I work on these 2 equations here, all right, I'm going to take this equation, I'm going to take this equation, and I'm going to get rid of my z. Because once I get rid of my z, I'll have my x and y. I have 2 in front of this z, but I don't have a 2 here. So I'm going to multiply this whole equation by 2. That's 4y minus 2z equals 2. And this one just comes along for the ride. 3x plus 2z equals 8. Now, if the signs are the same, then I subtract. Those signs are not the same, they are different. So if the signs are the same, I subtract. If the signs are not the same, then I do not subtract. I am going to add these 2 together. Now be careful. I cannot add 4y and 3x. That does not become 7yx. That just becomes 3x plus 4y, okay? These z's cancel, that's what I wanted, equals 2 plus 8 is 10. So now I have, okay, now I have a second equation. I'm going to say 3x plus 4y equals 10. Now I'm in a situation where I need to get rid of an x or a y. I'm going to get rid of the x because that happens to be the first one there. The numbers in front of the x do not match. I have a 4 and I have a 3. So what I do is I take my 3 up here and I multiply the top one by 3, and I take my 4 down here and I multiply the bottom by 4. And I'm going to get 2 new equations, and I'm going to combine those equations. So let's do this. That's 12x plus 9y equals 12. Okay? Now keep in mind, I need to do this for both. There we go. That's 12x. That's 16y. Woo! That's 40. Very good, very good, very good. Now, I look and I see I have my 12 here. I have my 12 here. The signs are the same. They're both positive. If the signs are the same, I subtract, which means I needed to distribute I need to distribute that negative sign into these parentheses. I'm going to flip all of the signs in the parentheses I just drew. So this goes bye-bye. This becomes negative. This becomes negative. And this becomes negative. And now I can combine my terms. Positive 12 and negative 12, gone. Okay. Positive 9 and negative 16 give me a negative 7y equals, okay, 12 minus 40 is negative 28. And if I divide by negative 7, I should know that my y equals 4. That's one of my three answers. Now, I have a y, okay? I can go literally anywhere with this particular equation. I can put a y into here to solve for this x. I can put a y into here to solve for this x. I should still get the same value. I can put my y into here to solve for this x, because that is one of the equations I had over here. Okay. I can also put the y here to solve for this z. I can do whatever I want. And you know what? I think I'm actually going to use this equation right here to solve for z, because that seems like the simplest one. Okay? If I have 2y minus z equals 1, and I know y is 4, that's 2 times 4 minus z equals 1. 8 minus z equals 1. I hope you should know at this point that 8 minus 7 is 1. So now I have my y and my z. All right? And you know what? I need to find an x. I'm going to use this equation right here. I'm going to plug my z in, and I'm going to find out what x is. So we have 3x plus 2 times z equals 8. So that's 3x plus 2 times 7 equals 8. Let's give ourselves a little bit more room. 3x plus 14 equals 8. And if I subtract 14 from both sides, I should get 3x, bang, equals negative 6. And if I divide by 3, x should equal negative 2. So I now have my three answers. I have my x, my y, and my z. They are negative 2, 4, and oh my goodness, 7. Whew! Like I said before, it's a lot of easy algebra, but it's a lot of algebra. There's a lot of multiplying, adding and subtracting, substituting. But you know what? We take our time. We make sure when we're multiplying, we're, thinking multiplication in our head. When we're adding, we're thinking adding. And we don't make simple mistakes, because you, yes, you can get this right every single time. And just when you start to feel some sort of comfort in what you're doing, boom! Here comes the real world word problem, and now you have no clue what you're doing. But you're with me, so you're going to know exactly what you're doing. Okay? Let's figure this out here. Let's read this word problem. College football playoffs. I love it. I love that we incorporated football into this problem. Love this problem where I got it. The University of Georgia and Florida State University scored a total of 39 points during the 2003 Sugar Bowl. The points came from a total of 11 different scoring plays, which were a combination of touchdowns, extra points, and field goals, worth 6 for the touchdowns, 1 for the extra point kicks, and 3 for the field goals. The same number of touchdowns and field goals were scored. How many touchdowns, extra points, and field goals were scored during the game? So they want us to write and solve a system of 3 equations and 3 unknowns. And we need to be sure to define each variable. So the first thing I'm going to do is I want to be sure to know what I need to solve for. Well, if I do this, touchdowns extra point kicks, and field goals. Okay? So, let my touchdowns, let T equal touchdown. Okay? Let E equal my extra points. And let F equal my field goals. Okay, you could have used lowercase letters. You could have used A, B, and C, A for whatever. I just like using T for touchdowns, E for extra points, and F for field goals because those words obviously begin with those letters. And I don't know, I like writing capital letters, so that's why I went with capital letters. All right, so here are our variables defined. Now, let's come up with some equations, shall we? Okay, the points came from a total of 11 different scoring plays. Okay? That means when I add up the total of touchdowns to the number of extra points to the number of field goals, because all of those are scoring plays, that should total 11. Okay? I have 11 different scoring plays. So there are 11 plays where we scored a combination of touchdowns, extra points, and field goals. So if I add them together, that should be 11. Let's go yellow. I hope you guys can see this. Okay. There was a total of 39 points scored. All right. Here's where it's going to get a little, you got to know your stuff. So if I add all of my scores with their values together, not how many scores I have, but if you add all of your scores together, okay, with their values, touchdowns were worth 6 points, right? So if I scored 1 touchdown, that's 6 points. If I scored 2 touchdowns, that's 12 points. If I scored 3 touchdowns, how many points would that be? That would be 18. So I multiply my 6 times however many touchdowns I have. So 6 times T plus my extra points are only worth 1. So I can write 1E, or I could just put E here because I don't have to write the 1 here. I'll put it there just because it's in our problem. And each field goal is worth 3 points. So if I add up all the values of those scores, it should be 39. All right. Now, we used blue, we used yellow. I hate to go purple, but let's go purple. I like purple, but I don't know how well you can see it. The same number of touchdowns and field goals were scored. What does that mean? That means if I scored 4 touchdowns, well, I scored 4 field goals. So my touchdowns actually equals the number of field goals I scored. All right? So let's really take a look at what we got here. We have our variables we defined. T represents touchdowns. E represents extra points. And F represents field goals. We know there were a total of 11 scoring plays. So if I add up all my touchdowns and extra points and field goals, there are 11 times that I scored. All right? The total points I scored was 39. If I take 6 points for every touchdown, 1 point for every extra point, and 3 points for every field goal, I should get 39. And now I know that I scored the same number of touchdowns that I scored on field goals with. Okay? There are my 3 equations. The first thing I'm going to do is I am going to take this last equation and I'm going to rewrite it. I'm going to subtract F from both sides, okay? And that's going to give me T minus F equals 0, okay? Because I like to have my number on one side and all my variables on the other. And I'm going to do this the same way I've done every other problem. I'm going to get rid of one variable in all these equations so that I have 2 variables left with 2 equations. And let's start. I'm going to take the first one and the third one. That seems easiest to me. Okay? So I've got T plus E plus F equals 11. And I've got T. I'm going to put my minus F here equals 0. And you can see why I picked these right away. Because in front of my F, it's 1F. And guess what? The signs are not the same, so I do not subtract. If the signs were the same, I would subtract. Here I add 1T and 1T gives me 2T. I just have my 1E here. And 11 plus 0 is 11. This is one of my equations with two variables. Now, I can pick two other equations to get rid of an F. Okay, let's see here. Let's see. Why don't we do the second one, because I have to pick the second one. And I can either pick the first one equation or the last equation. I'm going to pick this last equation. That's nice, like that. So I've got 6T plus 1E plus 3F equals 39. All right? And now I got T minus F equals 0. Now, I need to get rid of my F's, like I did right here. But you should notice that I have 3 F's here. I don't have a 3 here. I want a 3 there, so I'm going to multiply this whole thing by 3. 3 times T is 3T. 3 times my F is 3F. And 3 times 0, well, that will stay 0. So what I'm going to do is when I'm all said and done, that's what I have right there. Now, are the signs the same? No. So do I subtract? No. I add. And I've got 9T plus my 1E, bang, equals 39. Now I have two equations, both with a T and an E, and I can solve for one of them. Oh, this looks so nice. You might not see this. Oh, boy, but I do. I'll leave this right here. I have 2T plus E equals 11, and I have 9T plus E equals 39. I already have the same number, which is 1, in front of my E's. Are the signs the same? Yes. If the signs are the same, I subtract. And I'm going to distribute that negative sign all into the bottom. So it goes bye-bye here. Minus. This turns to a minus. And that also, the 39, turns to a minus. So I have 2T minus 9T should be negative 7T. My E's go bye-bye equals 30, negative 38. Okay? And right now, I made a boo-boo because that doesn't come out to be a whole number. If you caught the mistake I made, because I just did right now, good for you, because that shows a higher level of intelligence when you can catch mistakes. Look what I have here. 1. What should be there? 11. So, I'm actually going to have 11 minus 39, which is not 38. It's 28. When it doesn't come out right, you know you've made a mistake, and I'm not immune to them. Right? You got to go back and find out where you made it. If I divide both sides by negative 7, T should equal 4. I've scored 4 touchdowns. Now, here's where life becomes slightly easier. Isn't T equal to F? Wasn't that one of our equations? If I scored 4 touchdowns and T equals F, that means 4 equals F as well. Boom. So I've got 4 touchdowns and 4 field goals. No. No. I am going to use one of these three equations to solve for E. My bottom one does not have an E in it. This top one looks a million times easier. If I add them all three together, I should get 11. So, T plus E plus F equals 11. Well, I know my T is 4. I'm solving for E. I know my F is 4. That should be 11. Wow, that was a very ugly arrow. Man. 4 and 4 is 8. 8 plus E equals 11. I hope you know at this point in your high school mathematical careers that 8 plus 3 is 11. So, for my touchdowns, my extra points, and my field goals, I have 4, 3, and 4. Okay, you know what? Sometimes they like you to do these alphabetically, maybe E, F, T, but you know what? We wrote what order they were in. So that answer is right. We caught a mistake we made along the way to make sure we had the right answer, and we did some good work here. Gotta love it. Last, but certainly in no way, shape, or form least, money. Cha-ching, baby. Let's talk some money, okay? Problem number 5. A change machine contains nickels, dimes, and quarters. There are 75 coins in the machine, and the value of the coins is $7.25. There are 5 times as many nickels as dimes. Find the number of each coin, find the number of coins of each type in the machine. Write and solve a system of 3 equations and 3 unknowns. Be sure to define our variable. If you feel comfortable enough where you want to try this on your own, go ahead, pause it, do what you want, have a stretch, grab something to drink, have a snack, because we're going to do some math, people. All right, here we go. First, let's define our variables. Well, we'll say N equals nickels. No surprise there. D equals dimes. And I'm going to put F for quarters. I'm just playing with you. I'm going to do Q for quarters. Okay? Q for quarters. You could use A, B, and C. That's fine. I like using the letters that begin with the words, whatever. You could use capital letters like I like to, or lowercase letters. It doesn't matter. Let's start putting some equations together. We have now defined the variables. So, highlighter, green. We will do the following. There are 75 coins in the machine. That means we have a total number of coins, quantity, not value. If I take all the nickels, dimes, and quarters in that machine and count them, forget their value that they're worth 5 cents. If I just count the coins, there's 75 of them. So the number of nickels plus the number of dimes plus the number of quarters should give me 75. All right, okay. It's not too bad. It's not too bad. All right. Let's look at our next one. Oh, I hate to use blue and blue again, but let's do it because you know what? Blue's a cool color. Okay. The value of the coins is $7.25. What does that mean? If I take my coins and I figure out their worth, 5 cents for every nickel. So if I had 3 nickels, that'd be 15 cents because I multiply the number of nickels I have times the value of the nickels. So if I take 0.05 times my nickels plus 0.10 times my dimes, because each dime is worth 10 cents, and if I take 0.25 times my quarter and I add up their value, that should give me $7.25. All right? Not too shabby. And no, not the text pen. That's weird. I'm even trying to. Purple. There are 5 times as many nickels as dimes. Don't make the mistake that everybody here makes. All right? Don't say, oh, 5 times nickels equal dimes. No, 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 no. There are 5 times as many nickels as dimes. Okay? There are 5 times as many nickels as dimes. So, what do we got here? If I had, I don't know, 10 dimes, well, wouldn't I have 5 times as many nickels? So wouldn't I have 50? So I really got to multiply my dimes times 5, okay? My nickels is a bigger value. And if I'm going to set up an equation, okay, I need to, if I'm going to say my nickels, all right, are a bigger quantity than my dimes, I got to multiply my dimes to make it bigger so that it is equal to my nickels. Okay? I hope that makes sense, because explaining it with numbers like I just did there is probably the easiest way to do so. All right? So let's get started here. Let's get started here. I am going to, all right, just like I did in the previous one, set this one equal to 0. If I subtract 5d from both sides, I get n minus 5d equals 0. All right. I need to get rid of one variable. I am going to get rid of the n. Why did I select the n? Because right here I already have one n. And right here I already have one n. Okay? So I am going to combine my first equation with my third one. That's the first step I'm going to do. So I've got n. Yep, that's weird. I should probably get off the highlighter before I write. Ha, ha, ha. N plus d plus q equals 75. And now I have n minus 5d equals 0. Now, $1,000,000 question. Are the signs the same? Yes, they're both positive. If the signs are the same, I subtract, which means I flip the signs for everything in the parentheses here. Minus, plus. Yeah, 0, whether you have a minus or plus, doesn't matter. But we'll put a minus there. N's go bye-bye. 1d and 5d, 6d, plus my 1q equals 75. Nice. That's a nice. And now I need to get rid of n using 2 other equations. I have to use this one. And I'm still going to go ahead and use this one. It's a smaller equation. It's nicer to use. I'm going to go ahead and use that. So I now have 0.05n plus 0.10d plus 0.25q equals 725. That's this equation right here. Okay, and I have n minus 5d equals 0. These numbers are not the same. So I've got to multiply everything by 0.05. There you go. I do this. And there is no shame in using a calculator. If you need to, go ahead. We say 5 times 0.05, and you should get 0.25, absolutely. So when I distribute this, I get negative 0.25. All right. There's no q. And of course, another reason I picked this is because 0 times anything remains 0. All right. So let me rewrite this. Let me rewrite this nice. Okay. 0.05n plus 0.10d plus 0.25q equals 7.25. Wow. Now we have 0.05n minus 0.25d, no q's, equals 0. Are my signs the same? Yes, they're both positive. If the signs are the same, I subtract, which means I flip all the signs. minus, plus. I can put a minus there. Who cares? Bye-bye. Okay, if I add that, I get 0.35D plus 0.25Q equals 7.25. I now have two equations, God help us, that have a D for dimes and a Q for quarters. This one stinks. So let's do this. We now have this equation here, love it. This equation here, beautiful. And I'm going to combine them. I am going to say black. I have this here. I'm going to leave it, and I've got 6D plus Q equals 75. I am going to get rid of my Q's because all I need to do to the bottom equation in order to make the coefficient the same is multiply everything by 0.25. Whew. There's a lot of multiplying. These decimals get crazy, okay? So 0.25 times 6 will be 1.5. So when I do this, I get 1.5D plus 0.25Q equals, what is 75 times 0.25? 18.75. Wow. Let's just double check that. Yep, 1875. So that's my new equation on the bottom. This goes bye-bye. And I still have my equation on the top. 0.35D plus 0.25Q equals 7.25. The signs are the same in front of my Q's. I need to subtract. This problem is this is a very, very extensive problem here. And if you could do this, oh man, you're doing excellent. So if I subtract my dimes here, 1.5 minus 0.35, I get 1.15D. Okay? Because this turns to minus, this turns to minus, that turns to negative. These cancel, equals 11.50. If I divide by 1.15, I should get 10. If you don't believe me, 11.5 divided by 1.15, and you get 10. I have 10 dimes. That's a lot of work to get one answer because we have decimals galore here, okay? But what I'm going to do next, and just like the previous problem, is life is a lot easier now. If I know my D value, I'm just going to use this equation, N equals 5D. I'm going to find my nickels. Okay? So N equals 5 times D. Well, N equals 5 times 10, because that's dimes. My nickels, 50. Good. Now I need to pick one more equation to find my quarters. How about... You should know which one I'm going to pick. This one is so much easier. Okay, if I add up all my nickels, dimes, and quarters, it should be 75. So, nickels plus dimes plus quarters equals 75. My nickels, 50. My dimes, 10. I need to find my quarters. Okay, if I add these two, I get 60 plus Q equals 75. And once again, at this point in your careers, you should know that 60 plus 15 is 75. Holy smokes. Whew. Wow. Nickels, dimes, quarters, 50. 10, 15. God, I need coffee. That was crazy. Enjoy the rest of your day, will you? I'm out of here. I'm gone. I'm gonna hit a coffee shop. But Not Starbucks. So I don't like Starbucks. Maybe Dunkin' Donuts. Ooh, maybe Java's. Place is good. I'll see you next time for Unit 1, Lesson 15. See you.